I want to ask David Goldman from Celesta Capital to come up for our Fireside, where we're going to start talking about infra. A real quick show of hands. Who here, from a startup perspective, is running their applications on the cloud? Quite a bit. How about data centers? Anybody running in data centers? Okay, great. Very few, right? There's public, there's private cloud. So what we want to do today is we're going to talk a little bit about infrastructure. It's the picks and shovels, but I think we're going to dig deep, but we're going to make it really fun and understandable. So hopefully this is of value to you guys. As we're talking, though, if you guys have questions, just raise your hands. We'll answer them at the backside, okay? But the more hands that I see, the more time we'll save for questions, yeah? Because otherwise, I think me and David could talk about infra for like an hour, and you don't want that. You don't want that.
So I promise understandable. I don't know about fun for everyone.
Yeah, exactly. So let's get started. David, why don't you start with an introduction?
Sam?
Yeah, let's sit down.
Great. So I'm a partner at Celesta Capital. We're an early stage deep tech fund here in the Valley. Been investing for the last 12 years, about 100 startups, 76 still active. And we invest in companies that are building their company around a technology innovation. So that means usually semiconductors, systems. We do about 2/3 hardware, 1/3 software. Infrastructure software and AI are all huge areas of focus for us.
Okay, good. And David, I know that you and I met a couple months ago, and it was when you talk to another person that has deep infra experience, we just start geeking out. We got really excited, you know, and then so I'm really happy that you joined us today. So there's a lot of confusion right now. There's a lot of the hype, especially in the startup communities, right? We're taking a look at the Gen AI layers, and we just take for granted that the infrastructure layers will always be there, right? So what I thought was really interesting in talking to David is that he has a model, and it happens to be a model that we're also presenting in a lot of our events. But why don't you help describe kind of the different layers? How do we organize the applied and infrastructure and all that whole universe?
Yeah, absolutely. So I sort of think about AI as having these 4 distinct layers. So really at the base foundation is the infrastructure. So that's hardware, it's your compute, your networking, and everything you need to run the data centers or whatever infrastructure you're going to be using. A layer above that is the tools that you need to build the models, then the models themselves, and the applications on top. And so really where I think we're focusing this conversation today is that base level on the infrastructure. And it's really important, I think, today, that's where most of the bottlenecks in innovation are. I mean, if you were to ask, Sam Altman or Dario, what would be, you could snap your fingers, what was one thing you could have, they would all say more compute. And that could either mean more computation or better efficiency from the infrastructure that they have, and that can come through different hardware, different software, a bunch of different directions you can take it. But universally, I think they'd say that the bottleneck is in the compute.
Okay. And then let's dig into that a little bit more. So when you say compute and you say infrastructure, but what are kind of like all the other major pieces around that?
So you've got sort of your what I would call processor, although it's not a CPU anymore. It's more GPUs and different architectures there. You've got the networking around that. You've got the software to run the data center. You've got the interconnect between the data centers and different points of presence or wherever it is that you're going to be accessing it. And then all the way up to whatever software is going to be used by the application layer and communicating with that.
Yeah, no, that's a great point. And for everybody here in startup and this, we are Silicon Valley, I think this is a really important conversation just to at least think about early when you raise your seed round, before your A round, you have to start thinking about like how do you scale your infrastructure, right? And so we're going to have some tips later on at the back half of this. But let's talk about, we've been around a while where we see the pendulum swing back and forth. I started out in early 2000s selling Cisco gear to data centers, right? And so I'm part of the hardware is cool team, and then software, then it wasn't cool for 15 years, right? Now it's kind of swinging back, but you had some thoughts about like the waves of infrastructure this time around, right? Kind of gathering thoughts from the past. Can you share a little bit more about that?
Yeah, so we sort of think about there being 3 waves. I mean, there's more waves in wave 1, but to simplify, we'll say 3 waves of data center architectures. So you have the existing web architecture, which is where almost all of the world's data centers are right now, which is on the processing side built around CPUs, historically largely Intel CPUs, although increasingly in AMD. And then on the user experience side is really built around latency and giving this like snappy web experience.
Yeah.
And there's all of these statistics that came out of the consumer web companies about how improving latency led to so much more retention in their products. And so that gets put back into the infrastructure choices that drive their decision making on who they want to work with on the infrastructure side. So that's phase 1. We're in right now this giant build out phase around AI training focused hardware. So this is GPU centric architectures that are far, far more energy dense. So like an NVIDIA Blackwell server is, I think, 120 kilowatts per rack. Which is, I don't know, some like 20 times more energy dense than a traditional CPU-based rack would have been. And so you have long-running processes, which is what you're training these models on, super energy dense, not as important where they're located. And that's how you end up with these like 1 gigawatt data centers in the middle of nowhere in Texas and North Dakota and all of these places where maybe historically you wouldn't have put as many workloads because they're far away from the rest of people. And that's where we are right now, and that's where like all of the money and focus is going into.
Would you say that's the first wave still, or is it kind of the wave 1.5?
I think it's wave 2. I mean, it is a unique architecture relative to a CPU-based data center, right? So one example is in the way that you interconnect. So all of the rage is, talking about how big your cluster is among these companies. And, I think X has a 100,000 GPU cluster. And while you might have 100,000 servers in a data center in this wave 1, you would never need to have them all interconnected and be able to share memory amongst each other because it just didn't make sense. You didn't need to. So it's just distinct architecture, in particular in how you need to think about the energy density. And then we think there's going to be this third wave, which is going to come in who knows how long. It depends on how well everyone here does in making applications that demand infrastructure. Yeah. But where we're going to see a return to focusing on latency and focusing on cost as you move more into inference use cases and away from training. And so rather than thinking about the absolute tokens that you can have, you're going to be thinking about the cost per token and the latency that you can deliver in terms of user experience for applications.
Yeah, that's a really important topic. So if we're in phase 2, and we know, and I think that's the thing that we agree on is that we know that phase 3 is coming. Just because we've seen this pattern before, especially with streaming, right? We started building these data centers a long time ago that was like these monolithic, these are huge, and 2 in the east and 2 in the west, but then they weren't efficient to deliver content. Look at the like Netflix example, right? So what David is referring to is now we're building these monolithic, it's got to be big, it's got to be GPUs, and that's all the hype right now. But what we're seeing is it's going to shift, right? And then so when we talk about inference and edge, can you give a little bit more color around that? What does that really mean?
Yeah, I mean, I think most people here know, but if you don't, you train a model, that's when it's learning, then inference is when you're using it. In particular, most people think that inference is going to end up being a much larger market than training, both because you sort of train a model once, use it many times, but also because of the advances that have happened with reasoning models, which seem to show that the more time test compute, so the more compute power you put towards this reasoning, the better the output of the model is. And so there's a lot of trends that lead us to believe that inferencing is going to be even larger, and ultimately it is where people access the model. Like at some point you do need to make money from these things, and inferencing is the way that you're going to do that. Okay,
and then that's a great illustration. Maybe can you give the crowd a little bit more definition around edge, right? Because how much we want to get more intelligence closer to the user. That's kind of the general description of edge. But when we're talking in inferencing, does that stop at the data center, or does that go to the 5G towers, or is it down to your mobile phones? Like, where do you think inferencing is going to be hot?
Well, how much time do you have?
We have 17 minutes, sir.
I'm joking.
15 Q&A.
Broadly, the taxonomy I like on edge is like, I think there's on device, which you can think of as like your iPhone, or, it doesn't work anymore. I used to use Amazon Just Walk Out as the example for this. Yeah. I think that project is dead, but I'm still maybe going to use it. So like on device is like your camera itself. And then you would have what I call like local edge, which is like the server that's going to sit in this store. Then you're going to have local data center. So this could be like your content delivery network in the case of a Netflix. And then you have broad data centers. So something that might be in Data Center Alley in Northern Virginia. And depending on your need for latency and depending on how heavy that workload is, you're going to move things up that stack from device all the way up to global data center. So if you could run everything on device, you would, because it's basically free. I mean, you're paying for it by plugging in your iPhone at night. And so you're going to see innovation, I think, at every single piece of that in order to drive as close to the device as possible. Yeah. And so that innovation can be on the hardware side in terms of what NPU or what other processor is going into the device, but also in the software side in distilling these models and making them small enough to run in smaller environments.
Yeah, no, that's a great description, and it's something really key here, as far as, because we're all building together, right? So there's a lot of application folks here. Now you're going to try to say, okay, well, I want as much intelligence closer to the edge as possible. Can I do that on a mobile phone? No. Can I do that? And you kind of just keep on working up the stack. But at the same time, the infrastructure is getting more efficient and the edge is getting smarter. We're able to do more compute with less, right? Mm-hmm. So it's kind of like this moving ball. Like both sides have to talk to each other, but both sides is moving and evolving. So how do you see like that gets reconciled between the infra people and the applied AI people? Like what kind of conversations needs to happen?
A lot of it comes down to the end use case and the amount of money you're willing to put towards it and how much value is getting created. Mm-hmm. I think if you go to most businesses and you tell them, like, I need you to buy a server with an expensive GPU in it in order to run my software, they're going to say, that sounds like a big hassle. Yeah. So in many cases, you're going to need to either figure out how to get something on device or serve it to them through the cloud. So ideally, you could get them to buy that server, and then you wouldn't have to deal with cloud costs and running all of that through your business model. But it's just not feasible in a lot of cases.
Great point. Okay, a couple lightning points. These are really, really important in the infrastructure side of the world. We know that the next big bottleneck is going to be around data centers and energy. Any insights on how that's going to shake out over the next few years?
I mean, I wish I had a crystal ball. There's two big problems on the energy side. One is supply chain. So last 20 years, energy demand in the US grew at like a 0.5% CAGR. And then estimates are for the next 10 years, it's going to grow at a 20% CAGR. And that's probably the biggest difference you could possibly have in a market between two different growth rates. And so you had this entire ecosystem of companies who are built for a low to no growth industry suddenly tooling up for insane levels of growth, and you get shortages. And then the other side is on regulation. So there's like some 11,000 projects in the interconnect queue, which is like the wait to connect up to the grid in the US. More than half of them entered in the last 2 years. Average wait time for those is like 5 years. But if they were all approved, we would double electricity generation in the US. Yeah. And so on the one hand, I mean, like, I don't want to comment on politics too much, but like, on the one hand, if you say we're going to lower the barriers to connect to the grid, that could speed up that process. At the same time, if you get rid of the people whose job it is to review those and make sure that everything works, that's going to slow it down. And there's a trade-off between those two in terms of government efficiency and deregulation, and who knows where we're going to end up in that trade-off.
So Dodge is going to be involved one way or another.
It seems likely. I don't know.
All right. Wait, let's double click real quick, because I think a lot of people are curious. We're hearing we need a lot of energy, right? And then so the conversation is around alternative energy, off grid. What's your thoughts on micronuclear? Is that a possibility here in the U.S.?
Look, I'm not an expert on it. Nuclear fission is a process that works, that we know how to do. A lot of the questions are around what level of risk we are as a society willing to stomach and what degree of investment people are willing to put in. I mean, I think if you told Microsoft or any of the hyperscalers, I can guarantee you demand for your services for the next 20 years at X level, they would absolutely get it done to make micronuclear work to serve those data centers. But since no one can actually guarantee anything for 20 years, I think you're seeing a lot of commitments, and I don't know if all of those are going to come through.
Yeah, I think this last week Microsoft canceled some contracts,
Right.
and it only probably means they probably found a more efficient way to do something else, right? So, what about on the chip level? So everybody here knows NVIDIA, we know AMD, but then last year it felt like through our AI Infra Summit, it was like chip wars, right? Like everybody had an acceleration platform. You're either friends with NVIDIA, frenemies with NVIDIA, or you're trying to displace NVIDIA. What's like, if you take a look at the next 5 years in that space, what's the winners and losers and what's the patterns around that?
Yeah, look, there are a lot of companies in this space. We're investors in some of them. We're tracking a lot of them. I think broadly, if you want to go directly at NVIDIA, you need to have a systems level strategy. People who are buying NVIDIA today aren't buying it for the GPU, they're buying it for DGX. It's the GPU that's with NVLink and InfiniBand, and they have an amazing reference design, and it all works.
And CUDA.
And CUDA, obviously. They have an amazing reference design, and it all works, and you can put it right into the data center and build out quickly. And you saw AMD spend a couple $1 billion on ZT Systems to get that systems level capability in-house. And so if you want to go directly at NVIDIA for the big workloads in data centers, you have to have a system strategy. I think there's a lot of people in this market who can succeed without going right at NVIDIA. You don't need to make $20 billion of profit in order to be a successful startup. And there's lots of other markets where there isn't as much movement. So you can broadly think about it like where there is really rapid changes in software happening, like maybe at the frontier of LLMs, people are going to default to general systems because they don't know if it's going to change tomorrow and they don't want to pick something specialized that doesn't work with the tomorrow's version. But in areas where you can have something that maybe freezes a little bit in software, so take for example like autonomous vehicles, like I think there's a real opportunity for startups to compete for those platforms, because in an automotive platform you basically have to freeze the software for a couple of years, or at least create backwards compatibility, because the cars are going to be on the road for 10, 20 years. And so that you can pick a alternative to NVIDIA, and it's going to have to be backwards compatible.
Yeah, and we just talked about inferencing, right?
Yep.
And that whole from the core to the edge, that's a lot of road, that's a lot of the supply chain of data that needs to be covered. And then so do you see some of these, there's like chip to cloud companies, but we're really doing it for inferencing. Is that really the successful strategy for that?
I mean, I don't think anyone's really trying to go after training anymore.
Yeah.
You had some of the first wave of companies in this space, your SambaNova and Cerebras, I think are still trying to compete in training. Disclosure, we are an investor in SambaNova. But really everyone's going after NVIDIA within inference.
Got it. Okay. Now this is good. Hopefully you guys are finding this helpful. This is this is the picks and shovels talk. That doesn't happen a lot, right? So we really appreciate that people are listening. This is cool. Hey, this is cool. This is people having fun. So let's talk about maybe now let's take it to the audience, right? Which is, there's a lot of startups here. We were talking about how it's really important to have at least a conversation with yourself about how you will scale at Series A, right? There's this Hotel California effect of public cloud. You're crazy if you don't start in public cloud, but you're crazy if you stay. That was a quote from A16Z on their white paper about this, right? Which is great. But what are the things that founders here should start thinking about early on about their infrastructure strategy?
I think just be thoughtful and knowledgeable about the trade-offs that you're making. The Hotel California effect is more or less about getting caught off guard, having data gravity in one cloud, or not being able to transition between them either for cost or technical reasons. I think you're going to probably see something similar in people who try and build on some of the custom ASICs. So you're like Trainium or Maya out of AWS and Microsoft respectively, where there is a offered TCO advantage, but then you get a bit of vendor lock-in and you have some issues with needing to do probably software reports if you want to move. So just understanding where you're making trade-offs on cost and scalability versus the capability to be flexible in the future, and where you're getting locked in. It's not to say you shouldn't use any of these things, because maybe you should, like everyone's situation is different, but just know what you're getting into and be thoughtful about the trade-offs.
Yeah, it feels like there's the options are you grow up in public cloud and you get this inflection point, and then the GPU clouds are right there ready to also have you move your AI workloads there. But then there's the hosting. There's so many different options. Is there a good way to kind of think about or categorize in broad buckets, like the different paths?
I'm not sure I understand the question.
Yeah, so I guess when you get to a certain point, you hit that inflection point. You can go to GPU cloud. There's so many different providers, right? You can build your own data center, right? For those that are thinking like, when I say build your own data center, it doesn't mean you're building it, meaning like you're building your own private cloud within a data center, right? What are kind of the key maybe signals on the founders should think about that really drives them towards, hey, I need to have my own data centers?
Yeah, I mean, I think the things to be thinking about, like cost, obviously, how predictable your demand is. So if you're, for example, in a regulated industry where every customer I onboard is going to have to go through a certain flow, I'm always going to be growing in a way that I'm like able to predict and map out 12 months in advance, that gives you a lot more capability to control your own infrastructure. Whereas if tomorrow you might break out and 1 million people are trying to use your product and you can only support 100, you would have really wished you were in public cloud at that point. So predictability of demand, and then I think the uniqueness of what you're working on. I mean, if you're doing something that's completely optimized to a specific type of hardware, I would prefer to own that hardware myself rather than be reliant on someone else, because I don't want changes in their architecture to affect the way that my product runs.
Fantastic. Now, for the other side of the room, the investors. I heard the question is like, how do we discern hype from substance, in the applications layer? Now, for infrastructure, if there's investors here looking to invest in infrastructure, what are top 3 things they should be mindful of?
I think first is that right now everyone is talking to everyone. So when you're talking to a company and they say, yeah, we're having a discussion with, and I'm just picking names out, I'm not, Microsoft, we're talking to NVIDIA, we're talking to AWS. They're talking to everyone about everything all the time right now. And so there's not a lot of signal in the fact that they're talking with you. And so just keep that in mind. It may mean something, but it may not. I think, unfortunately, it's not an area where you've seen a lot of first-time founders have huge success, or when there is, it's oftentimes because they're working with experienced founders or experienced investors. Just because oftentimes in hardware, the iteration cycle, if you screw up the first time, requires so much money that it can kind of make it difficult for you to survive. It's not to say it can't be done. Love to see it when it is, but that's just tends to be an observed trend.
Yeah. All right. Let's open it up for questions. Is there anybody have questions for myself or David?
Sorry, when I say first-time founders, I mean people doing this thing for the first time, not someone who's doing it in a startup for the first time. If you've been doing it 100 times in a big company and now you're doing it,
You know what? That's a really good distinction, because in the application side, with a fresh principle, you can create anything, right? So you have younger, newly grads, creating really awesome stuff. But infrastructure, like, having a gray beard is like the first bar to be able to kind of really understand the depth and the history, right? So do you really kind of look for that for certain founders?
Yeah, I mean, if you're going to do, for example, semiconductors on the leading edge, and you're going to spend $20+ million on your mask set, I want to know that you're going to get it right.
It's not just a concept.
Yeah.
It's going to work. All right. So any questions from the crowd? Yeah. Any questions? No? Oh, we got one.
Thorough.
Thank you.
Hi. I see a lot of people making AI hardware, and I can think of other applications for that, but the guys making the hardware never want to talk to me. You invested in Samba Nova. Can you introduce me to people there?
Yes. I mean, I don't know who you are, but
We could talk about that.
We could talk.
yeah.
You had a question about energy.
Besides the energy infrastructure that is being built right now, maybe we might want to consider actually is industry thinking perhaps putting it instead of just middle of nowhere in Texas, perhaps putting in Canada where they actually have a lot of energy right now, or some other places where there's going to be surplus of energy that is going to be happening. Do you see a fundamental shift on compute power moving to different locations altogether?
Great question.
Yeah, no, it's absolutely happening. I mean, you're seeing it in Saudi Arabia. I mean, Korea just announced a 3 gigawatt data center park. I think you're seeing people flock to wherever they can get energy, whether that's rural Texas or, there's a trade-off in sort of stability. Like, I'm not sure yet people are going to go to some of the less stable countries that have energy, like your Kazakhstans, for example. But certainly places that are U.S. allies with relatively stable governments. I mean, Canada, I think, meets those criteria.
We were friends with Canada until last week. So yeah, no, and then the only thing I want to add to that is, a lot of the requests that we're seeing is for infrastructure within the U.S. A lot of geopolitics is behind that. After the Trump election, there's a lot more outside money that wants to invest in infrastructure within the U.S. There's a lot of family offices, like real estate focused family offices, that's really making that move. And then I think there's also going to be, and this could be a larger conversation, but around sovereign AI. Each country or each region is going to have they want to have data sovereignty. They want to be able to build their own models. I think that's going to be maybe that's phase 3 in your model, phase 4,
phase 3.
maybe, yes, somewhere around there. But yeah, so it is right now the demand is all U.S. The next is U.S. friendly countries or regions, and then we go from there. Pavel, did you have a question? Go.
So when is the right time?
When is the right time for startups to start thinking about switching to their own GPUs, and which techniques do you think the best for optimizations there, like quantization or whatever other you recommend on that stage? Yep.
Well, I think it depends a little on what you're doing. Like, that was sort of the framework I was trying to talk about before. You have cost considerations, you have sort of scalability considerations. I think no matter what, you're going to want to have access to some of your own. If what you're doing, if having access to those is core to your capability to iterate, I would have some experimental capacity that would be my own. Sorry, I can't hear.
As early as possible.
Yeah, as early as possible for some amount of the workload, if having access to GPUs is critical to your capability to drive product forward.
David, thank you so much. This has been an
Thanks a lot
awesome
for having
chat.
me, Bill.
Yeah. Thank you, everybody.